GS is equals to K S plus 2. Okay, GS is equals to K S plus 2. So 1 plus GS of HS is equals to 0. So what will it become? It will become 1 by, so you have to construct in this way. So see, 1 by K of S plus 2 is equals to 0, as HS is 1. So see, K is equals to minus of A square minus of 2S. So you have to write, what you have to do, you have to write K in terms of S. Okay, and the third point is to dk by ds. Okay, find dk by ds is equals to 0. So you have to differentiate this in terms of S. So what will it become? Minus of 2S minus of 2 is equals to 0. So S is equals to minus 1. So S is equals to minus 1 is a breakaway point. So you have to check whether it is a valid breakaway point or invalid breakaway point. So what to do? You have to put S is equals to minus 1 in this portion. So see, minus of 1 square minus of 2 minus of 1. So what will it become? Plus 1. So as a condition is, if K is equals to positive, then valid breakaway point. So S is equals to minus 1. So S is equals to minus 1 is the valid breakaway point. Okay. See. Then next comes to the general prediction about breakaway point. So what are the general predictions? First point is, the branches of the root locus either approach or leave the breakaway point at an angle of 180 degree n. So n is equals to number of branches approaches or leaving the breakaway point. Okay. So you have to remember these points. Means the root locus, the breakaway point will be either approach or leave the breakaway point. Means the root locus will either approach or leave the at an angle of 180 degree n. And see here. See. This is 180 degree by 2. Okay. Why it is 180 degree by 2? See, because there are n. N means see. So there are 2 branches. So there is n. N means n is equals to 2. Next point is complex conjugate path. Complex conjugate path for the branches of the root locus approaching or leaving a breakaway point is a circle. So till now we are taking only the real portion of the real path of the real path. But if there will be a complex path, then it will be automatically become a circle. The root locus will become a circle. And the third point is, whenever there are 2 adjacently placed poles on the real axis, whenever there are 2 with the section of the real axis between them, then there exists a breakaway point between the adjacently placed poles. Means this is one pole and this is one pole. These 2 poles are adjacently placed. So there will always lie a breakaway point. So this is the breakaway point. So there will always lie a breakaway point between the adjacently placed poles. So this is the points. So you have to remember these points. So I am now next continuing with one example of adding a pole to transfer function. So what is the effect? So what is the effect of adding a pole to a transfer function? See, if you add s plus 4 in the pole section, if you add s plus 2, s plus 4, s plus 8, so what will be the effect? See, here S is equals to, in poles, S is equals to 0, minus of 2, minus of 4, and zeros, Z is equals to 0. So P minus of Z, what will it become? 3 minus of 0 is equals to 3. Number of asymptotes. So number of asymptotes is 3. So there will be 3 angles. So see, theta 1 is equals to 60 degree. Theta 2 is equals to 180 degree. I am highlighting this portion. 180 degree, and theta 3 is equals to 300 degree. And centroid, you have to calculate similarly the centroid. So see. And what you have to do? You have to plot this portion. So first of all, you have to solve the breakaway point. Okay. So see, you have to write k in terms of s. So then you have to differentiate the dk by ds in terms of you have to differentiate k in terms of s, and then equate with 0. So s will come minus of 0.84 and minus of 3.15. So see, poles are at zeros, minus of 2, minus of 4. Okay, as you guys can see, and the breakaway point is at minus of 0.84 and minus of 3.15. Okay, so you have to check which breakaway point we have to take. See, minus of 3.15 is not in the portion of the root locus. See, from s is equals to minus 2 to s is equals to minus 4, there is no root locus. Okay, there is no root locus. So you can take this breakaway point. So this breakaway point we don't take. See, next we have to check this s is equals to minus of 0.84. See, from s is equals to 0, s is equals to 0 to s is equals to minus 2. There is one breakaway point, that is minus 0.184, and there will be one root locus. So you can conclude that s is equals to minus 0.84 is a valid breakaway point, because we have to check whether this point will lie on root locus or not. Okay, see, so here you plot this, and from minus 0.84, sorry, and centroid is minus 2. See, centroid is minus 2. So what you are doing, you are taking the angle of asymptotes. Wait, I am showing you. See, this will be one angle. This is minus of, so as centroid is minus 2, so this is a minus 2 point, so you have to draw the angle of asymptotes, and angle of asymptotes are 60 degree, 180 degree. So 180 degree means this portion, this line, so you don't need to draw this, and this is 300 degree. Okay, and next this is the portion of the breakaway point. So you have to, what you have to do, you have to take it parallelly like this along the asymptotes. So this is the breakaway point, and this will be the root locus. See, okay, and what you have to do again, you have to check, you have to find the value of k. So how you could find the value of k? By putting s is equals to minus of 0.84, you can find the value of k. So what is the final conclusion? See, so final conclusion is root locus determine for what value of the k the root locus is stable, unstable. Means the value of k determines the root stability and the instability of the root locus. For adding k, stability is decreasing. Okay, so this is the ultimate conclusion. So till now we are watching that what are the effects of adding a pole to the transfer function. Now I am going to show you of adding a zero, effect of adding a zero to the transfer function. Means g of s is equals to k by s plus s plus 0. This is the adding of 4. If adding of 0, there will be one 0 term, s plus 1. So see what are the effects. Same way you have to first find the poles, number of the total poles, zeros, the total number of poles and zeros. Then you have to find the asymptote angle, asymptote angle. Okay, then you have to find the centroid. You have to solve through these steps. Then you have to find the breakaway point. So breakaway point is s is equals to minus 2.8. okay, s is equals to minus 2.8. So same numerical, you can see that in previous numericals there is no s plus 1 term in the zeroth portion, zero term part, and the breakaway point is in minus of 0.84. But after adding s plus 1 in the zero portion, the breakaway point shift to minus of 2.8. So this is the conclusion that if you solve, you could see this. If we add zeros in the transfer function, stability increase, root locus shift to left side. Means initially this is in minus of 0.84, but after adding 0 to the transfer function, the breakaway point shift to minus of 2.8, means this portion. So root locus will shift to the left hand side if we add zeros in the transfer function. Okay. Similarly, you have to solve this like this. Then comes to the intersection of the root locus with imaginary axis. Intersection of the root locus with imaginary axis. See. So this is the root locus, and this is the imaginary axis. This is the root locus and this is the imaginary axis. So what you have to do? You have to find the intersection portion, means this and this. So what is the value of this intersection portion? You have to find. See. So how did you find? You have to find through Routh-Hurwitz equation. Okay. See. GS is equals to K s into s plus 2. So you all know that how to solve Routh-Hurwitz equation. If you don't know, or if you want to know, then you can see the comment description box. There I will provide the link of the Routh-Hurwitz. Okay. So see, this is s plus 2, s plus 4 plus k is equals to 0. Like this you have to follow, because I am representing this in terms of 1 plus gs hs is equals to 0. This is the open loop transfer function, so you have to represent it 1 plus gs hs is equals to 0. So after representing, you will get this. So then what you have to do? You have to solve through Routh-Hurwitz. So s cube 1 8, then s square 6 k, then s1 this into this minus of this into this 6, then s0 of k 0. The root, then see, the roots of the auxiliary equation as at k is equals to k max from Routh-Hurwitz gives the intersection of the root locus with the imaginary axis. Means you have to find the k max. K is equals to k max, and this will give the intersection of the root locus. See. So after solving, you will get this and this k term. So you have to compare. See, 48 minus of k by 6 greater than 0. So 48 greater than k. So you can, and k. So you can. So this is the range of the Routh-Hurwitz, 0 less than k less than 48. Okay. So k is a marginal 48. Max, k max is 48. So what you have to do? You have to take the auxiliary equation. So what is the auxiliary equation? See, if you put 48 here, then what will happen? This will become 0. Okay, so this will become 0. So 0 0 term. So we have to take below So if it is 0, so S1 is 0, then we have to find through auxiliary equation. So we have to take this. So what will it become? 6x square, and km marginal is 48. So 6x square plus 48. As you guys can see, 6x square plus 48. Means after calculating, S is equal to plus minus of J 2.8. And the omega is, so if you compare with J omega, then omega will be find plus of 2.8 radian per second. Okay. Next you have to find intersection of asymptotes with J omega axis. Means this is the intersection of root locus with J omega axis, and this will be the angle of the asymptotes with J omega axis. So how to find? As you know, tan theta is equals to y by x. So see, theta is 60 degree. So you are taking this angle. Theta is equals to 60 degree, and y by x. And what is the value? So you have to find the value of the y, because y is the imaginary axis. So what is x? X is the centroid. Okay. From where you draw the angle of asymptotes. So centroid is minus 2. So you have to take 2 here, mod value. So then y will become 2 into root 3 tan 60 root 3. So it will come plus minus of j 3.4. Okay. So this is become j 3.4, and this will become minus of j 3.4. So this is the conclusion. And last but not the least, what is this step? Last step is angle of departure and angle of arrival. See, so what is the angle of departure? Angle of departure is obtained when complex pole terminate at infinity. Okay. And what is the angle of arrival? Is obtained at complex zeros. So we find angle of departure in case of complex poles, and we find angle of arrival in case of complex zeros. Okay, because complex poles are terminate at infinity and complex zeros are terminate at 0. So this is the formula. Phi of d is equal to 180 degree plus phi for angle of departure. Angle of departure, this is the formula, and 180 degree minus of phi is equal to phi a is the formula of the angle of arrival. Okay, and see, and the phi, the formula of the phi is summation of phi z minus of summation of phi p, means 0 minus of poles. Okay, so I am showing you one example of how to find angle of departure and angle of arrival. Only I will show this portion. See, we are taking here gs is equals to k s plus 4 s plus 4s plus 20. So angle of departure is, so see, so s is equals to, there is one pole at s is equals to 0, and at s you solve s square plus 4s plus 20, then it will be complex pole. So this is minus 2 plus minus of j4. So what will it become? It will become this. Okay, this is minus 2 and this is j4 minus of j4. So you have to take this angle. So first of all, what to do? You have to join all the poles from this point. See, then you have to find the angle. So you have to find the angle. So this is one angle, phi d1, phi p1, pole angle. This is one phi p1. This will be one phi p3, and this is phi p2. Okay. So you have to consider all the angles from each pole. See, as there is no 0, so we don't write the 0th term. Okay. So see how to calculate phi p1. Phi p1 is equals to 180 degree minus of tan inverse of, see, tan inverse of, this is a 4, first the y-axis portion, so 4 minus of 0, and then 0 minus of minus 2, q, y, so 0, this is 0 portion, so 0, we have to check this angle, so 0 minus of minus 2, 0 minus of minus 2, after taking tan inverse of 4, so similarly it will come 116.57. Similarly, if you calculate 5p2, this one, if you calculate this one, you are going to show that this 5p2 makes an angle 90 degree. Okay, so 5p2 is 90 degree, and this 5p3, similarly you have to calculate 4 minus of 0, tan inverse of 4 minus of 0, minus of 2, minus of 4, becomes 63.4 degree. So why it is 5p1 is, why it is 180 degree.